Now you're probably asking, okay, this is cool. We have company B routes here. What about company A? Well, let's take a look at that. And again, I use this one with an underscore to show that you can use underscores. Here is the routing table for company A. You'll see you have BGP routes coming from the other site. Though that these BGP routes are coming all the way through the MPLS cloud. You can see that they're originated from 5.5.5.5, which is the other PE router. You can see some OSPF stuff from the locally connected company A site 1. And there you go. Now I can actually ping these as well. I would have to do ping VRF CPNY underscore A. And let's ping something on the other. Let's ping something through the BGP cloud. This one here, 172.18.3.1. Look at that. Now notice if I do the same thing and I leave out the VRF, if I don't tell it to ping from inside that virtual routing forwarding instance, this is not going to work because it doesn't know how to get to that network. That network is not in the table. So notice also if I do show, let me just do that. Let's do show IP route 172.18.3.1. Network's not in table. Now if I do VRF, look at that. Routing entry for 172.18.3.1, known via BGP, autonomous system number 65,000, distance 200. I'm redistributing it via OSPF2, advertised by OSPF2. So I learned this from BGP and I'm redistributing this into OSPF. And now if we go back to the VRF one more time, which pinging is not what I wanted to do. Let's go back and look at the table. Let's look at something at OSPF. Let's do a show IP route VRF CPNY underscore A. And let's look at something learned via OSPF 172.16.2.1. And this is interesting. Known via OSPF, instance 2, look at that. I don't think you guys have probably ever seen 2 instances on one box before. If you're not familiar with MPLS, but you can run multiple instances of OSPF. So known via OSPF2, distance 110, metric 33, type intra-area. Redistributing via BGP, so we're sending this to BGP. It's advertised by BGP 65,000, which is the autonomous system number. There you go. So you can see that we are doing two-way route redistribution, and we're doing it safely and efficiently. Now, VRFs don't need BGP, they don't need OSPF. You can do really cool things with VRFs. So in your core network, let's say you wanted to have a connection that pointed to a proxy server for the whole company, but executives on a special network, let's say you have a penthouse floor. On that floor, you have a special VLAN. You could say that with a route map very easily. You can say packets coming from this network when it gets to your core router. So, packets coming from this network, set, instead of next hop, you could set the VRF to be, let's say, unfiltered. And that way, everybody goes through the proxy except for the executives. They get a different default route that doesn't put them through a proxy. So there's really cool uses of VRFs you can use, even inside companies that have nothing to do with ISPs or any of that other craziness like we're looking at here. So you've seen that the routes are working. You've seen how they're separated into different tables. So let's take a look at the nuts and bolts, the meat of this configuration here. So the first thing you have to do is create your VRFs, right? That's step one. That's what you want to do. You see we have our two VRFs. Remember, the route target is always going to be the autonomous system number you're using. Now, that's important to know that before you get to this step. So it's something to think about. As for the route distinguisher, you do not have to use the loopback IP. We're just using it for this example. If you have another number that represents where these things are originated from, where these routes are originated from, you can use that. As long as it's easily referenceable. Loopbacks are generally easily referenceable because any engineer can come in, see the loopback, find it, whereas like a inventory number probably isn't as easy to find or troubleshoot with. We have our loopback. We have our interfaces. Now this is different from the other multi-link interface, which is why I wanted to show you these. Typically, when you go into an interface, you put interface, fast Ethernet, Ethernet, gigabit, multi-link, whatever it happens to be, and you put the IP address. You cannot put the IP address first when creating VR interfaces and moving them under a VRF. The first thing you have to do is add the interface to the correct VRF table, and you do that by using the IP VRF forwarding company A. Now, I want to go in here real quick, go into config mode and go to interface multi-link 1, and I want to do IP VRF question mark. I want to show you that there's a couple options there. Now, these options are beyond the scope of today's video, but they are very useful. If you want to add an interface to a VRF table, maybe you don't want to actually forward packets on it, but maybe you want that VRF to know about that interface. There's a use for that, especially if you're going to have packets destined for a certain interface that are on two different VRF tables. Sitemap is very similar to a route map, so you can say that you can create a sitemap saying that all the routes I receive from this network, I want to do A, B, and C with it. So you could have routes going to multiple VRFs. You could do all kinds of really neat different things with those. So I highly recommend that you take a look at the Cisco iOS 12.4 documentation under VRFs. There's a lot that you can do, and there's some really cool things that you can solve some interesting problems using those. So let's go back here to our show run again. And I want to get through this because we have a lot to talk about here. So the first thing you do is add the VRFs. The next thing you do is add your interfaces to those VRFs. Now you're only going to add the interface to the VRF if you want those packets to go into that routing table. So you wouldn't add all your interfaces. You would just add the interface that's going to get the routes or send packets to a destination through that VRF. So for instance, this VRF is specific to company B or company A, so we wouldn't put other interfaces in there, because then we would get routes and packets into that virtual routing table that we don't want. So that's the first thing. The next step of things we have to do is, let's look at OSPF. So the first thing we do is, I'm going to highlight this because we don't want to look at the BGP configuration yet. Let's look at the OSPF configuration. That's your typical OSPF configuration. We got the loopback, we got the two Ethernet cables, loopback. The next thing that you want to do is create an OSPF instance for each VRF. And the reason why you want to do that is because you need something to peer with the client. So the company A is running OSPF, company B is running OSPF. So you need something to take routes with them, send routes to them. So the way you do that is you create OSPF. Now you know, if you've ever done OSPF, it says instance. You can't use one, that's already there, so you have to use two, but it won't let you create two, because you cannot have two routing instances running on the same routing table. It's a no-no. So you have to actually put the VRF in there. And what that does is that moves OSPF underneath that VRF. And then you add the network. In our case, this is the 192.168.20 or the 150 address on the other side. You can also put 0.0.0, and this will pick up just the 150 address. It'll pick up any connected interfaces under this VRF. Again, I did it both ways to show you that you can do it both ways. That you don't have to explicitly say the networks, it will pick it up. The other thing we're doing is redistributing BGP 65,000 subnets. Now here's the thing. Remember at the very top when we created the VRF, we had a route target. Let's go back up here. Route target. This will only, no matter, even if we're redistributing routes from OSPF, and even if we're receiving routes into this table, if they don't have this community string, they are not getting into the table. So this protects us in our OSPF and BGP configuration from redistributing the wrong stuff into our table, which can happen sometimes. So this is your OSPF setup. The next thing we have to do is configure BGP, which is a little bit more complicated, especially if you're not familiar with BGP. If you are familiar with BGP, it's a very straightforward, simple setup.